Hello everyone and welcome to this section. In this section, we're going to look at a practical classification example, which is kind of tied strongly to self-driving cars. And then what we're going to do in the next section, which is kind of the fun part, we're going to take all the learnings that we have. How can we build a single neuron model or a perceptron model? How can we apply kind of a little bit of training? How can we classify? How can we divide the data set, for example, a training data set and testing data set? And how can we apply different activation functions to build our first model in Python? Okay, so let's take a look at a practical example first, so we can actually deal with data that has meaning. And then the next section right away, we're just going to start coding. Okay, so the first step is in this practical example is to first let's assume that we have our truck here, and let's assume that we have a bump. Okay, and we have a distance d, which is a distance away from the bump. Okay, along with the height of the bump. Okay, and what we need to do is we need to kind of like code the truck in a way to perform a decision. Okay, in a very simple form. That's a very simple example. Either we're going to drive the truck fast, we're going to drive the truck slow. Okay, all right. So here on the x-axis we have our distance, okay, which is away from the bump. Here we have our height of the bump. In a very simple form, if our height of the bump is high, okay, that means the speed of the truck has to be low. Okay, that's the first step. All right. Or if the distance, for example, here to the bump is very near, is very close, okay, then we make the speed again of the vehicle low. We don't want to have it fast, and and we jump basically over that bump in a very simple form. So again, if we are near and we are driving high, okay, or sorry, and the bump height is high, then our speed will gonna be 0. In 0 here, that means we're driving slow, class 0. Okay. On the other side, if the bump is far, if we're far away, or the bump is low, okay, which is the height of that bump is low, then we're gonna drive a class 1, which means fast. And that's kind of the data set that we have. Again, this is a very simple data set. There is no overlap. It's very simple. The objective here, I try to make it simple in order to, because we're going to use a single neuron model. It's just we want to get an actual results. Okay, one neuron, it's very difficult to get anything out of it. But we're actually going to we're going to use it to classify this simple example. Moving forward, we're going to try to make it way more complex. And that's where we actually try to add more neurons as we go, more hidden layers, more activation functions, different activation functions, and so on. Okay, that's a very practical, simple example that we're going to use in our section. All right. Next concept that I wanted to show you guys is how can we assess our training and our testing. Okay, what we do is that we use what we call it confusion matrix. Okay, and that's very important concept. It's actually used, like pretty much everywhere to have kind of a one-stop shop that you can look at the data and can tell you exactly how accurate our trained model perform. Okay, so what we do is that we assume here on the rows is our predictions. On our columns, that's our true class. Okay, that's the true value. That's, for example, that can tell me, for instance, plus means there is a pedestrian, minus means there is no pedestrian. Okay, that's our true class, which is 1 or 0. Here, this is our predictions. That's our kind of, our network telling me, plus that means, okay, there is a pedestrian. The network predicted that there is a pedestrian. Or minus, which means the network said, okay, there's no pedestrian. Okay, all right. The first step is, well, if my model predicted that there is a pedestrian, which is here, that means, okay, true, and in fact, there was an actual pedestrian in there, which is a true class, was actually pedestrian, then that means we're true. That means we're good. So what we do here, simply put, we actually put within that block, we put the number of correctly classified samples. If let's say we have 100 samples, and let's say 50 of them are within that class, if the network classified them all correctly, that means, okay, here we're going to put 50. That means this network has successfully classified the values of 50 samples correct. Okay, all right. What if the network, for example, predicted that there is no pedestrian, which is here minus, and there was actually, in fact, there was no pedestrian? That means we're good, and then we're going to put the number of true negatives here. All right. That's basically the good part. Now to the trouble, okay? Now to the issues, now to the problems. First step is if my prediction, if my network said there is a pedestrian, however, there was no pedestrian, then there is a problem. There is a false, okay? There's what we call it false positive, okay? All right. The next problem is, which is, well, that's why I highlighted in red, that's when the issues or the problems arise. That's when the network said we're okay, we're good, there is no pedestrian, however, there was a pedestrian right there. That's the issue, okay? And that's why when we classify errors, we classify this error as what we call a type 1 error, and this error we classify as a type 2 error, okay? And we are actually worried about type 2 error. That's a problem. Why? Because the vehicle won't take any decision, okay? If it says, for example, that, if the network said it's fine, we are negative, that means there's no pedestrian. However, there was actually a pedestrian, that's an issue, that's a problem. And that's why we try to avoid type 2 error at any cost, okay? Obviously, we would love to have, like true, all of them correctly classified, but type 1 error can be, I don't want to say tolerated, but it's kind of, like not as severe as type 2 error. However, would love or we wanted to have zero errors at any case, okay? And that's pretty much a summary of the confusion matrix. I hope you guys enjoyed it, and let's move to Jupyter Notebook. We'll actually start to code our first artificial neuron, okay? I hope you guys enjoyed this section, and I can't wait to go to the next section, okay? See you guys.